5.2, we're kind of continuing off of what we had for 5.1. We're still dealing with the z-score stuff, but we're going to have to actually calculate out the z-scores now before we can find our areas or our probabilities here. So here for this first one, we want to go through and assume here that we're doing a survey here of 150 students, and we find that the average GPA is 2.7 with a standard deviation of 0.72. And we want to find the probability that a randomly selected student from the survey had a GPA of, for part A, we want 3.0 or higher. So for these, what we want to do is first of all, go through and calculate out the z-score. So here for our z-score here, for our z, what we're going to have is we're going to have our value. So for the value for x, as they write it in the book, you'll have 3. It's the number that you're trying to figure out the probability related to, minus the mean. So here that would be our average. Remember, average is another term for your mean, which is 2.7. Divided by the standard deviation, and the standard deviation here was 0.72. And for the z-scores, always want to round your z-scores to 0.42 because remember in your normal distribution chart, it only goes out 2 decimal places anyway. And make sure to remember your rounding rules that if that number after that last place value is 5 or higher, you want to round up. If the number after that last place value, that hundredths place, is below 5, if it's 4 or less, keep that decimal point the same. So make sure to remember your normal rounding rules as well there, so that way you're looking up the correct z-score value in your table. That'll affect what you get for your values here. So here, if we look up a z-score of 0.42, remember that means we're going to have to go down to 0.4, or in this case, I would say 0.4 in your chart, and then go over to the column that has 0.02. That will represent your decimal of 0.42 for the z-score. So if you get that, you'll get 0.6628. But remember, in the table, just like it shows in the chart, right above it in the normal distribution always gives the area to the left of the value. In this case, we want the area or the probability here of being above 3. So to find it above or to the right of that value, remember we have to do 1 minus that area, 1 minus that probability from your chart. And remember once again that your areas and probabilities are really finding the same values whenever you're using your normal distribution chart there. They're just 2 words that are calculating the same thing there, finding the same values. It's being used for the same values there. So if we subtract those, we get 0.3372. And then that would be your final answer for this one. So remember there, if it's asking for above or to the right of that value, we have to do 1 minus that area that we found in the chart whenever we looked up the z-score of 0.42. So look that up and then do 1 minus it since it was above that we were looking for in that case. If it was below, then it would have been just the 0.6628. So make sure you're keeping in mind that as well whenever you're going through and finding these values. So for the next one, we wanted between 3.2 and 4.0. So once again, we want to go through, find our z-scores here first of all. Once again, you're going to have one for both of these values. So for the 3.2 is the value minus the mean. Same mean here, same standard deviation. So it's value minus the mean divided by standard deviation. That order does make a difference because remember if your value is above the mean, then you should have a positive z-score. If the value you're looking at is below the mean, it should have a negative z-score. So you do want to make sure you're getting the signs correct on those as well. So here for the first one, you should get 0.69. And for the other one here, for the 4.0, 4.0 minus the mean, divided by the standard deviation again. For that one, we get 1.81. Make sure you're careful once again in terms of rounding. Make sure you're getting those z-scores rounded correctly and round to 2 decimal places up to the hundredths place here for these. And then remember, if we're looking at between two z-scores, between, remember, means that we need to subtract the areas that are related to both of these. Remember, always do the bigger one minus the smaller one, because otherwise you're going to get a negative area or negative probability. And you can't have negative probabilities. Negative areas and negative probabilities do not make sense for these, so make sure you're doing it in the correct order. So if we do the 1.81, we look that up, we go down to 1.8, over to the 0.01 in the chart. We do so here, we get 0.9649. Remember, I just did the bigger one first, and then the other one, and we go down to 0.6, or in the chart it'd be 0.6. And then you have to go all the way over to the 0.09 column, which would be the last one in your chart. So there you get 0.7549. Once again, you're subtracting there because you're finding that area in between. You can also think of it in terms of your curve if that helps you to think of it visually. Now you have your two z-scores, you're finding the area in between those. So you have to subtract the area because the chart just gives you the area all the way underneath there, not in between to begin with. So then whenever you subtract those there, you should get 0.21. So that would be for the area in between those two values. And then if we want less than 2, again, just like the other ones, calculate the z-score corresponding to the 2.0 first. This one, we definitely expect it to be a negative z-score because 2.0 is less than the GPA of 2.7 for the average. That's less than the average, less than the mean. Should have a negative z-score. So here, if we calculate that, we get negative 0.97. And then since we want less than it, less than also means left of that value on the normal distribution curve. So if it's left of it, remember that's just the value that's given in the table. You don't have to subtract it by 1 or anything. So if we look up a z-score of negative 0.97, we're going to have to be on the negative side of our chart. And then you go down to the negative 0.9, and then over to the 0.07 column. If you do so, you should get 0.1660. Once again, there's no subtracting or anything you have to do there, because if we're talking about less than that value, that negative 0.97 z-score, that's already this area to the left. And if you're looking at the top of your chart there of your normal distribution, it does show you that the chart, the values they're giving you are the area to the left. Those values are areas to the left. So remember, the areas are also finding your probabilities. So find your probabilities, same thing as finding the area from your normal distribution chart. Keep in mind as you continue to work on these problems.